Welcome to Cyber Explain channel. Today we are going to discuss IAM demystified, directory services and federation, like coffee chat. Hey everyone, and welcome back. Today, we are going to demystify some of the foundational pieces of identity and access management that often work behind the scenes. You know, those things that make logging into multiple systems feel seamless. We'll be chatting about directory services and federated identity management. Think of it as the digital address book and the trust system that lets you visit friends' houses without needing a new key for each one. Sounds interesting, right? Let's jump in. So, imagine your company or an organization. It's got people, devices, applications, all sorts of things that need an identity. A directory service is essentially a highly organized, searchable database that stores all this identity information. It's like the ultimate contact list for your digital world, keeping track of who is who and what they can potentially access. Instead of having separate lists everywhere, it centralizes this crucial data. One of the most common protocols you'll hear about for directory services is LDAP, that's Lightweight Directory Access Protocol. Think of it as the universal language that applications use to talk to directory services. It defines how to query, add, modify, and delete information. It's been around for a while, and it's super foundational. Many systems still rely on it to find and authenticate users, even if they're using more modern systems on top. Now, when you think of large organizations, especially those heavily invested in the Microsoft ecosystem, Active Directory, or AD, is probably what comes to mind. AD is Microsoft's implementation of a directory service built on top of LDAP. It's incredibly powerful, managing users, computers, groups, policies, and so much more within a Windows domain. It's the central brain for identity in most Windows networks, controlling who can log into what. Inside these directories, identity information is typically structured using attributes. Think of an identity like a person. Their attributes might be their username, first name, last name, email, employee ID, department, and so on. These attributes are key-value pairs. So, for John Doe, the attribute might be with and the value John Doe. The directory organizes these objects, like users, and their attributes in a hierarchical structure, kind of like a tree, making it easy to find specific information. Directory services don't just store info, they are critical for providing access. When you try to log into an application, that application often queries the directory service. It says, hey, is this user John Doe valid? What are their group memberships? Do they have the right to access this resource? The directory answers these questions, enabling the application to authenticate you and then make authorization decisions based on the information provided. But here's the snag: often, different organizations, or even different departments within a large company, have their separate directory services. Imagine you're a scientist working across several research institutions. Each institution might have its own login system, its own directory. You'd end up with a different username and password for each one. That's a pain, right? And it's not great for security either. More passwords means more chances for them to be forgotten, reused, or compromised. This is where Federated Identity Management, or FIM, swoops in to save the day. FIM is all about establishing trust between different identity providers and service providers. Instead of each organization managing its own separate identity for you, FIM allows you to use your identity from one trusted home organization to access resources in another trusted organization. It's like having a universal passport for digital services. At its core, FIM relies on trust. Your home organization acts as the identity provider, IDP, it knows who you are and vouches for you. The destination organization is the service provider, SP, it trusts the IDP and accepts its assertion that you are who you say you are. When you try to access a resource on the SP, it redirects you to your IDP. You log in there, and your IDP sends back a secure token to the SP confirming your identity and what permissions you might have. So, in a federated model, your identity information isn't duplicated everywhere. Instead, your home IDP shares just the necessary attributes with the SP. This could be your username, your role, or maybe a unique identifier. The SP uses this information to grant you access. This dramatically reduces the administrative overhead for the SP and improves your user experience, as you don't need to create and manage a separate account there. For federation to work, there needs to be a pre-established trust relationship between the IDP and the SP. This often involves configuring protocols like SAML, Security Assertion Markup Language, or OAuth. You'll exchange metadata, basically, a description of how each party can communicate securely and what information they'll exchange. Think of it like exchanging business cards and agreeing on how you'll communicate before you start working together. Let's bring this to life with our research consortium example. Imagine a group of universities and research labs collaborating on a big project. They have a shared data platform. A scientist from University A needs access. Instead of creating a new account on the platform with a separate password, the platform, the SP, is configured to trust University A's identity system, the IDP. When the scientist tries to log in, they are sent to University A's login page. After authenticating, a token is sent back to the data platform, granting them access using their university credentials. Before federation, each scientist would need an account on the shared platform, managed separately. This means IT staff at the platform provider have to onboard, offboard, and manage credentials for researchers from dozens of institutions. It's a nightmare to keep track of. Plus, researchers get frustrated with yet another login to remember. It slows down their ability to access vital research data. By implementing FEAM, the consortium can simplify things immensely. Each institution becomes an IDP for its own users. The shared data platform acts as the SP, trusting the IDPs from each participating institution. Now, researchers simply use their existing university login to access the shared platform. This dramatically reduces the administrative burden on the platform provider and offers a seamless experience for the researchers, accelerating their work. This approach is fantastic for any scenario involving external partners, vendors, or suppliers. Instead of creating and managing separate accounts for each of them, you can trust their organizational identity. This is especially useful for business-to-business, B2B, integrations where partners need access to your systems or data, but you don't want the headache of managing their individual accounts. And for cloud applications, federation is a game changer. Many SaaS applications, like Salesforce, Microsoft 365, or Google Workspace, support federation. This means your employees can log into these cloud services using their corporate Active Directory or other enterprise identity credentials. No more separate cloud accounts. This ties cloud security directly into your central IAM policies, making management much more cohesive. SAML is a popular protocol for federation. When you try to access a federated app, the app, SP, sends you to your IDP. You log in, and your IDP generates a SAML assertion, basically, an XML document containing information about you, like your username, roles. This assertion is digitally signed by the IDP and sent back to the SP. The SP verifies the signature, trusts the assertion, and lets you in. It's a standardized way to securely exchange authentication and authorization data. While SAML is great for full authentication, OAuth is more about delegated authorization. Think of when an app asks for permission to access your Google Calendar or Facebook photos. It's not authenticating you ** to Facebook, but asking Facebook, as the IDP resource server, to grant * the app ** as the client, specific permissions * on your behalf *. It uses tokens to grant limited access to specific resources, which is fantastic for mobile apps and APIs. OpenID Connect, or OIDC, builds on top of OAuth 2.0. It adds an identity layer, making it an authentication protocol. So, you can use your Google account, IDP, to log into another website, SP. OIDC simplifies the process of getting basic profile information about the logged-in user, making it easier for web and mobile apps to implement single sign-on experiences powered by established identity providers. SAML is often preferred for enterprise-level single sign-on between organizations or for accessing corporate cloud apps. OAuth is your go-to for API access and third-party application integration where you need to grant specific permissions. OIDC is fantastic for user-facing web and mobile apps that want to leverage existing social logins for a smoother sign-up login experience. The identity provider is the system that authenticates the user and then issues security tokens or assertions. In our research consortium example, each university's identity system is the IDP. They know the researcher, they verify their password or MFA, and they say, yes, this is Dr. Smith, and they are a valid researcher. They are the source of truth for that user's identity within their domain. The service provider is the application or resource that trusts the IDP and relies on it for authentication. In our example, the shared data platform is the SP. It doesn't need to know how Dr. Smith logged into University A. It only needs to trust that University A's IDP has verified Dr. Smith's identity correctly. The SP then uses the information from the IDP to decide what Dr. Smith can access. One of the biggest wins with Federation is centralization. You are not managing identities across dozens of systems. Your central IDP, like Active Directory, remains the master for your organization's identities. This simplifies management, reduces errors, and ensures that when someone leaves, their access is revoked from all federated services by disabling their account in the one central place. For the end user, Federation means a much better experience. They can often use their familiar corporate login to access a wide range of applications, both internal and external, including cloud services. No more forgotten passwords. No more trying to remember which login goes with which service. It makes their day-to-day work much smoother. From a security perspective, Federation can actually improve security. By centralizing authentication and relying on your strong corporate identity provider, you enforce consistent security policies across multiple services. If your IDP supports multi-factor authentication, MFA, that MFA is automatically applied to all the services your users access via Federation. This reduces the attack surface and prevents credential stuffing attacks across different platforms. Now, it's not all sunshine and rainbows. Setting up Federation, especially between multiple organizations, can be complex. You need to understand protocols like SAML, configure trust relationships, exchange metadata securely, and troubleshoot when things don't work right out of the box. It requires specialized knowledge, so it's not something you can always set up in 5 minutes. Another crucial trade-off is your reliance on the identity provider. If your IDP goes down, say, your Active Directory becomes unavailable, then users can't log into any of the federated services. This is why high availability for your IDP is absolutely critical. A single point of failure for authentication can bring down a lot of your services. When you federate, you are essentially sharing identity attributes. It's vital to ensure that you are only sharing the minimum necessary information. Oversharing attributes can lead to privacy concerns. For example, an SP shouldn't need to know a researcher's exact date of birth if only their role and affiliation are required for access. Careful design and adherence to data privacy principles are a must. When you implement Federation, You are explicitly deciding to trust another organization's ability to manage identities and secure their systems. This trust relationship needs careful vetting. You'd want to understand their security practices, their compliance certifications, and how they handle data. It's like inviting someone into your house. You'd want to trust them first. How do you know if Federation is working smoothly or if there's a problem? Log analysis is your best friend. You'll want to monitor authentication logs on both your IDP and the SP side. Look for failed login attempts, certificate errors, metadata mismatches, or unexpected attribute claims. Security Information and Event Management (SIEM) tools are invaluable here for correlating logs from different sources. For any organization, it's wise to start with a pilot. Maybe federate with one trusted partner or one key cloud application first. This helps you learn the ropes, iron out kinks, and build confidence before rolling it out more broadly. Test thoroughly, document everything, and train your team on managing the Federation infrastructure. Having clear, well-defined roles and attributes is crucial. In our research scenario, clearly defining what researcher means and what access that role grants simplifies the Federation setup. Ensure your attribute mapping between the IDP and SP is precise. If the IDP sends a role attribute as scientist and the SP expects researcher, access might be denied. Federation isn't a set it and forget it thing. Trust relationships can change, certificates expire, and protocols get updated. Continuous monitoring of your IDP and SP configurations, as well as the flow of authentication traffic, is essential to maintain security and functionality. Regularly review trust relationships and update metadata as needed. So, we've seen how directory services like LDAP and Active Directory are the foundation for managing identities, and how Federated Identity Management, using protocols like SAML, OAuth, and OIDC, allows us to extend that identity and trust across organizational boundaries. It's a powerful way to simplify access, enhance user experience, and bolster security. Thanks for joining me today. Thanks for watching. Subscribe to the CyberExplain channel. See you on the next video.